Hi there everyone, today we're going to have a look at all the different types of percentage questions you could be asked. So, we're going to start off really basic, just with increasing and decreasing by a percentage. Now, there's lots of ways of doing it, but what we're going to be looking at is the most efficient way. So, there's nothing stopping you finding 12% by finding 10 and 1 and doubling it, combining those and adding it on. It takes way too long. So what we're going to do is use percentage multipliers. So we always start with what we're increasing, and it's called a percentage multiplier because we always multiply. Now if we think of 64 being 100%, when we add on 12%, we now get 112%. That's basically what the question says, work out 112% of 64. A percent means per 100, okay, so divided by 100. Which is the same as 1.12. So if I times something by 1, it obviously stays the same. If I times something by bigger than 1, it gets larger. So we want to make it bigger by 12%. So if I just go ahead and do that, I get 71 and 68. Okay? So moving to the right here, we've got increase 36 by 2.1%. Okay, so that obviously is a bit of a harder percentage, and if you're going for the old-fashioned way, I'd probably go for 21% and then divide it by 10. It's definitely easier than faffing around with 0.1%. But if you're using percentage multipliers, it's very easy. So it's going up, so it's 1 point something. Well, it could be 2 point something if it's going up by like 108%, for example. But if this is 100%, and we're basically adding on 2.1%, so we end up with 102.1%, which is the same as 102.1 divided by 100. So just move that decimal point back 2 places, so 1.021. Now obviously I don't do this every time, I just say, right, 2% would be 1.02, and I just chuck the 1 on there as well. So what is that? That is 36.756, so not much of a change, but there are my answers. Now decrease, some people find it harder. You've just got to be a bit careful with it. So if we're going to decrease now, what we've got is 100%, but we're going to be taking away 9%, so we end up with 93%. So we want to make it smaller than what we started with, so it's called a percentage, it's not called a percentage rule, right? It's called a percentage multiplier, so we're going to put multiply. But if we want to make something go down, we're going to multiply it by something less than 1. And this is 0.93 as a percentage multiplier. Remember, percent is per 100, and 93 per 100, or divided by 100, is 0.93. So that will make it go lower, and that takes it down to 65.1. Okay, so 362 decreased by 33%. So if we're taking 33% off, we're going to have 67% left. Okay, so if we times by 0.67, we will find 67%. Okay, that's what we want. So 362 times 0.67, which is £242.54. So they could even ask you easier questions than this, like for example, find 12%. Let me just squeeze this one in. Right, so let's say it says find. Let's do 12% of £385.21. Okay, so it's not a very nice number. So all you would do is use your percentage multipliers and find 12%. So it's going to get smaller. So you just do that. Okay, times it by 12%, 12 over 100 is 0.12. Okay, so I'll just do that as well. What do I get? £46. Well, yeah, if it's money, okay, so we're going to stick to 2dp and be 23 pence. Right, but they're the easy ones. I expect you to be able to do that. So let's have a look at this one. The wording always makes things a little bit harder. We've got a picture here of the greatest basketball player ever. Oh, look at that. It's awful. I'm going to correct this live because I'm ashamed of myself. There we go. Capital J for Jordan. Now they're playing against their rivals, the Cleveland Cavaliers, and he scored 38 points in his first game and 46 points in the second game. Now I've just said here, calculate the percentage increase. They could say percentage change between the two games. What I mean there is the change in his points between the two games, I probably should have said. Now there's loads of different ways of doing this, and when I look at these methods, I'm like, why are you changing your method? Why don't you just keep it exactly the same? So basically, it's a little bit in disguise, this one. So we've got 38, and if I said increase 38 by something, you would times it by something, right? And what we're getting is 46. So I'm going to set it up exactly the same way. I can see it's gone up, so I'm going to set up a percentage increase, but this time it's a little bit backwards, okay? I haven't got my percentage, but I've got what it goes to. So if I divide both sides by 38, it's not a particularly nice number. I get 1.2105, blah, 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 blah. So that is my percentage. This bit here is my percentage increase. So there's a change by 21%. Okay, they might say 2 sig figs, 3 sig figs, whatever they say. I'm just going to go for the whole number. This is an increase of 21%. If you're ever uncertain, you could just type in 38 times 1.21. It's not going to be exactly it because I've had to round it. But we actually get 45.98, so it's pretty darn close, and you know that's right. So another popular topic is compound interest. Okay, so you often get this when you put money into a bank account. So that's exactly what we've got here. So we've got £350 going into a bank account, which offers 1.4% interest per annum. That's what the PA stands for, every year per annum. You keep the money in there for 5 years, and what is the balance at the end of the 5 years? Okay, so the balance means what you have in your account, not what you make, what's in there. So what you could do is you could just keep timesing this by 1.014. Okay, that's the percentage increase multiplier for this. 5 times. Now that takes a long time, but I'll explain it, okay, this way. So if I times it by 1.01, that would be 1%, so that must be 1.4%, okay? That's going to increase it by 4%, and then the next year, I would do the same, and the next year, and I'd have to do that 5 times. So you can see the same number is being repeated 5 times. What we can do is say 350 times 1.014 to the power of 5, rather than typing in every time. So that's much quicker using percentage multipliers, and that is one of the reasons why we push it so much on the early, easier topics. Okay, so that gives me £375.20 when you round it correctly. So basically you've just got £25.20 for free, which doesn't seem great, but to be honest, this is not a real life. No one does this. No one puts £350 in and just leaves it. They normally put £350 in a month with that interest, so obviously it goes up quite a lot, but that's an A-level problem, so we're not going to worry too much about that. But if you were to leave it, how long is it going to take for you to get that £500? Maybe you're saving for a bike. You're not going to like the answer to this one. So this is basically the problem, right? So we've got our bank account, which is going to give us 1.014%, but we don't know what to put there. But what we're trying to get is 500. So it's just trial and error. If you want to, you can divide by 350. And actually, there is a method, it's called logarithms, but we're not at the stage to learn about those yet. So you just basically guess. Now, if you put 26 in here, which I'm just going to do, so it's 350 times 1.014 to the power of 26, you get just over 500. You get £502.41. Now, if I was to put 25 in there, you'll see that it comes just under £500. So you've got to wait 26 years to get £150. But like I said, this isn't realistic, it's just a little problem. This one's slightly better, as a very nice car, well out of my price range. So a Porsche 911 GTS, now 57 grand. You've got to be a mug to pay that for a car. Now it's going to depreciate by 12% a year, right? So depreciate, what does that mean? It's going to go down. That's why cars are a really bad investment. So £57,000, it's going to go down, so we're going to be timesing it by 0 point something. So after 1 year, it's going to lose 12%, so actually it's going to be worth 88% of what it was originally. But we're not after 1 year, we're after 3 years. So instead of timesing it by 0.883 times, we can use a bit of clever notation and put it to the power of 3, which I'm just typing in now as we speak. And it's now worth £38,843.90. Now, if you can afford 57 grand for a car, you might not care that you've just lost all that money. For me, I'll be crying. So that's why I don't buy expensive things. Right, so that's another compound interest problem. So sometimes it goes up, sometimes it goes down, and you just got to think, is it 1 point something or 0 point something, basically? Right, reverse percentages. This is the area that people find the most challenging. And it's just the language that's hard, not the actual question themselves. So we've got a delicious looking hockey stick here, the Grays GR 11000 Pro Bow. It's on sale. This is a legitimate advert. It's 43% off. It's now only £172. If you're not a hockey player, you might be like, crikey, what idiot's going to pay that on a hockey stick? Me. Right? I'm that idiot. Now, what was it originally? And this is how you identify reverse percentage. They quite often use the word originally, or they can dress it up in different words like, what was it before this happened? Okay? So, what we've got is, this is £172 and it's had 43% off. So this is actually worth 56%. That's not 56, is it, you idiot? It's 57% of the price. Now it's really important to write this opening statement. Now again, there's so many methods online. The unitary method is my favorite. Okay, so you write a fact that you're given, you then find 1%, and we're going to do that by dividing by 57 because we have 57%. So if I divide 172 by 57, I get £3 and 2 pence. Okay, so now I times that by 100 to get 100%, and it's £301 and 75 pence. Now that you've got to be crazy to spend, 43% off. Look, I'll prove it to you. It's real, and I'm very, very tempted. I'm going to move on and make more videos, so I don't have any time to buy that. But it's delicious. Now, Michael is looking, I don't know if he's looking happy, he's looking a bit of a fake smile, but he's just received a pay rise of 6%, so he should be happy. He now earns £240 a day. How much did he earn before the pay rise? Okay, so what is the fact we can write down? Now the mistake is what I should have said before in the last one, is people just decrease it by 6%. And in fact, let's just go back to here quickly. Now, what a lot of people do, they increase this one by 43%. Now, if you do that, so just times it by 1.43, you'll see that you get £245.96. That's nowhere near the amount. Okay? So, come back to this. So, what we can't do is decrease this by 6% because it's a reverse percentage, but we have to write a fact. So, what we know now is 106% of what it was originally is now £240. So if we use the unitary method, find 1 unit percentage by dividing by 106. So how did I know this is reverse percentage? Because they're hinting here about this original thing. What was it before this change happened? Okay, so 240 divided by 106 is equal to £2 and 26 pence. So we times it by 100, obviously there's something else here, right? It says a 4 and a 1, for example. When we times this by 100, we get £240 and £26.42 because that one rounds up because there's a 5 after it. So that's your lot. So we've got compound interest, we've got basic increase and decrease, and we've got reverse percentages. I'm going to just let you practice all of these.